All right, so we are solving linear equations. This is review from, gosh, way back when. First of all, let me ask you this question. How do you know an equation is linear? Yes. Correct. You have x to the first power and no other, so you don't have an x to the first power and then also an x squared somewhere else in the problem. You also don't have a variable in a denominator, for example. That would make it rational. So if I'm looking at our example right here, I only have x's to the first powers. So this is going to be a linear equation. All right? So do you remember how to solve these ones? I'm just going to recopy it here. Did you guys try this one already? If you didn't try it yet, go ahead and try it. See if you can remember most of what you should be doing. Our end goal here, I only have one variable. I only have an x. So I want to get the x by itself. But before I can do that, I might simplify both sides. Yeah, me personally, I'd probably distribute on both sides first. And then try and get my x's together on one side, and then move all the other numbers to the other side, and then solve for x some kind of way. All right, so let's try that if you haven't already. So remember, when you take the number out in front and then you multiply it to each of these, that's called, yeah, that's a distributive property. So that's a negative 2x, and it's a minus 14. Look at your paper, because that's a common mistake to only do negative 2 times the x, and then a lot of people drop the negative for some reason. So if I have something like this, I just call it a negative 2 times x and negative 2 times 7. Okay, so there we go. And then on this side, 3x plus 9. So make sure you distribute it. All right, now I still can simplify on each side before I start adding things left and right. Okay, so if I just look at this left-hand side, I can combine the negative 3 and the negative 14. They're like terms. So if I do negative 3 minus 14, where do I end up? Yes, negative 17. Same thing over here. I can combine the 4 and the 9, 13, 3x. Okay, now it's kind of up to you if you want to add the 2x over, or you could subtract the 3x over. It doesn't matter. I like to keep my x's positive. So by adding, I'll end up with a positive 5x, but it's not necessary. And then I'm also, at this stage of the game, I think we can do this step at the same time too, minus the 13 over to this side. But if you don't feel comfortable and you want to do it two separately, fine. But if I have negative 17 minus 13, I end up at negative 30. And then over here, I have 5x now, because those are gone. So just dividing by that 5. Did we all end up with a negative 6? All right, good. So the nice thing about equations is that you can check your answer, right? You can now take negative 6 and plug it back into the original and verify that it really does work. Okay, and it should, but that's one of the nice things about math, is that for most of the things you can check them. Sometimes it's not always convenient to check them, right? Especially if your answer is some sort of crazy fraction, but you can do it. So that's convenient. All right, so that's how we solve linear equations. If you take a look at number 2 on this review packet. So I'm just going to recopy that one here. Okay, so this is also a linear equation. Do you think you know what to do? Yeah, I mean, there is a smart way and a hard way to solve this one. So, give it a shot. Do what you think you're supposed to do. And we'll see what we get out as some answers for this. If you have an answer and you're willing to share it, let me know. Yes.
Negative 7 over 2.
Negative 7 over 2. Any other answers? So everybody got negative 7 over 2? What'd you get?
Negative 7 over 4.
Negative 7 over 4. What else? I have no idea what the answer is, so I have no idea if these are right or not. Go ahead.
Well, I got 3.5.
3.5? Okay. Positive?
Yeah.
Oh, sorry. All right. Any other ones? Any other answers anyone wants to throw into the ring?
Oh, wait.
Go ahead.
It's actually negative.
Okay. All right, let's see. So, how many of you, raise your hand if the first thing you did was distribute that 3? That's probably what I would do too. So, let's do that. 5 halves x. Now, when you are distributing a 3, remember it's really 3 over 1. So when you multiply fractions, you just multiply numerators and denominators together. So hopefully you got 15 over 2x. And then 3 times 1/3 is just 3 over 3, or just 1, right? So now you're here. So you have some options. We can combine like terms right here. What's 5 halves and 15 halves? 20 halves, right? And 20 halves is really just 10. So I get 10x, and then I'll just minus that 1 over to the other side, so I get a negative 35. And then divide both sides by that 10. So, oh, I'm so glad that nobody gave me an answer of negative 35 tenths, because you know you have to reduce fractions always, right? Yes. So, I agree with the negative 7 over 2's, which is the same as negative 3.5. You don't ever have to worry about changing it to a mixed number. That's old school, so where you can leave it improper, that's no problem. So, we got lucky in this one that all the fractions kind of just went away on their own. What happens when they don't? Like, what might you do for a problem like, I'm just going to make it up. What if you had like 1/3 x minus 4/9 equals, oh, I don't know, how about 2/5 x? What would you do with this? Yes.
Multiply the whole thing by the least common denominator.
Yes. You should clear fractions if you can. We didn't have to here. If at this step those two didn't combine so nicely, I would have cleared them right there. I would have distributed the 3 and then multiplied everything by 6 in this case. But I didn't have to because they kind of went away. Here, nothing's going away nicely for me until I multiply everything by, what would it be in this case? The problem is the 9. You need a number that 3, 9, and 5 can all divide into. Yep. 45. So if you multiply everybody by 45, this should clear the fractions. And the easy way to do it, you're just going to divide down, multiply up. So if I do 45 divided by 3, that's just 15 times 1 is just 15x. And then I do the same thing. 45 divided by 9. 5 times 4 gets me 20. See how easy? Look how nice. 45 divided by 5. 9 times 2. 18. Now I have such a much easier equation to deal with. Okay? So if you have fractions that you can't get rid of, you can if you just multiply by that least common denominator. Okay? Divide down, multiply up. Divide down, multiply up. And now it becomes a very easy problem, right, to finish this. Oh, it still comes out. Oh, no, it doesn't come out nice. I got excited. Almost. So negative 20/3 is my answer for this one. Okay, so just keep that in mind with fractions. We can clear them. What about decimals? You see in number 3, that one has decimals in it. You can deal with decimals just straight on. But does anybody remember what else you could do with the decimals? Yeah. Yeah, in this case, so I just look at, see what I mean? You guys are already not telling me. Whoa, here we go. All right, so here is number 3 from that packet I gave you. In this case, this guy has 1 decimal place. He has 1 decimal place, but he has 2. So if I want to clear the decimals, I want to multiply everything in this case by 100 because he goes out 2 decimal places. If I had someone that went out 3 decimal places, I could multiply by 1,000. And that gets rid of all the decimals and all the numbers. So whoever has the most decimal places, you would just multiply by whatever number you would need to clear their decimals. So in this case, yes, I should multiply everybody by 100. So what I'm really doing is just moving that decimal 2 places to the right. So what does this first number become? If I do these two, it's now going to be negative what? 110. And this thing would now be 240. And then that just ends up being the 325. And now I can just solve without having to worry about the decimals and the rules of decimals. If you have access to a calculator, it's not such a big deal. But sometimes you don't, right? Like when you guys go to take the SATs, there's a whole section that's non-calculator. My sophomores, you'll be taking MCAS in the spring, right? There's a section that's no calculator. So a problem like this, if you have to divide by a fraction, I mean, you can, it just gets really annoying and you have to remember all the little rules and where does everything go. So it just makes your life easier. Here I can just combine, these are both like terms, right? So that would be what, 130? And then just reduce that fraction. So, oh gosh, well 5 certainly goes into both of them. And by half, how many times? 65? And what? 26? I believe you. And it doesn't look like I can go any further than that. Okay, so is this ringing any bells? Yes? Okay, I think we have time to, was it 41 that this ended? Or 31? 31? Let's just try number 4. I'm just curious what you think you're supposed to do. By the way, does anybody know what the name of these are? Yes, this is an absolute value equation. So, I'm so curious if you remember how to solve that. Yeah.
Aren't there 2 solutions?
There are 2 solutions. Here's what you don't do. You don't just ignore the bars and solve it like you normally do and then say it's plus and minus that number. That is not what you do. I'm fairly confident that you guys can find one of them, but I'm wondering how many people remember how to find the other. Did everybody get 9? 9 is one of the answers. What's the other one? Negative 15 over 7?
51.
Oh, 51 over 7. Yeah? And where do you get that from? Yes. Okay. Yeah, so the first thing that you need to do when you're solving an absolute value equation, you want to get the absolute value all by itself on whatever side the equal sign that's on. So we're going to start off by adding that 3. 7n minus 6 is now equal to 57. Now, before we keep going, you remember what absolute value is, right? It's how far a number is away from 0. So if I ask you what's the absolute value of 3, of course it's 3. And likewise, the absolute value of negative 3 is also 3, because they're both 3 units away from 0. So if I ask you this, the absolute value of what is 5, let's say? Well, yeah, x could have been 5 or negative 5 to make that true. So because I could have a positive 5 in there or a negative 5 in there, that's where this second answer comes from, because whatever's in here could equal negative 5. To make it true. So I kind of use that same idea. Whatever is in here could equal 57, but it could also equal negative 57. So once you have the absolute value by itself, your next step is to rewrite it twice. So once you set it equal to positive 57, and then the next time you take what is in there and you set it equal to negative 57. That's what is most often forgotten, to rewrite it that second time, setting it equal to the negative value. And now you just solve each one. So we get the one answer of 9, but the other answer is not negative 9, right? If you do this math out, you get negative 51/7. So such a common mistake to just say, oh yeah, it's positive negative 9. No, it's not. Okay, we will talk more about absolute value